Hi guys, we're still on 2D shapes. In this lesson we're going to be working with similarity. Similarity meaning that two shapes, for example, have the same shape but they have a different size. So the one's small, the one's big, but they're the same shape. The symbol for similarity is 3 strokes downwards. So if you want to say that two triangles similar to each other, you would say triangle ABC and then 3 strokes down, which means similar to triangle CDE, whatever it is. Okay, so similar triangles are similar if all of the angles are equal to each other or if the sides are in proportion. Okay, so let's deal with the first reason first. So angle, angle, angle. So 3 angles that are equal to each other. If I have a look at these 2 triangles here, at first glance it doesn't look like they're similar to each other, but if I go and calculate the angle that's missing, so over here if I calculate R, I know that angles in a triangle add up to 180, so that means that R is equal to 35, because 35 plus 45 plus 100 is 180. Then if I go and do the same here and work out the angle of S, I'm going to find that S is equal to 45 for the same reason. Now I can see that all 3 angles here are the same as all 3 angles here, so the 2 triangles are similar. Okay, sides in proportion, this is what it looks like. Okay, here's my 2 triangles. I can see the side lengths here. So this is 5 centimeters, 12 centimeters, 10 centimeters, and then these ones are different, obviously. But if I were to try and see their proportion, when I do that, I can see actually the sides are all in proportion. So the way that you do that is you go, okay, this is my shortest side here in this triangle, and this is my shortest side here. So I'm going to write that as a fraction. Okay, same thing here. I'm going to write the 10 and 20 as a fraction, and over here I'm going to write the 12 and 24 as a fraction. So that's what it looks like. So I've got 10 over 20, 5 over 10, 12 over 24, and all of those simplify to a half. So I can see that all the sides are in proportion. If I simplify their fraction, it simplifies to the same fraction or the same number. Okay, so let's do some examples. Okay, prove that triangle ABC and triangle ADE are similar in 2 different ways. Okay, so if they ask you to prove that 2 things are similar in 2 different ways, there's only 2 ways you can prove it. You can either show that all the angles are the same or that the sides are in proportion. So I'm going to split it up and I'm going to take away the side lengths for now. Okay, so there's my angles only. Alright, my format is very similar to congruency. So I'm going to start by stating which triangles I'm working in. So let me just move the one triangle down. Okay, so I'm working in triangle ABC and triangle ADE. Then from there I can state which angles are equal to each other. Alright, angle B is equal to angle D, E is equal to C, and then angle A is equal to angle A. And because they were sitting on top of each other, I don't say given, I say common angle. Okay. Alright, then I'm going to say, well, therefore the triangles must be similar. So triangle ABC is similar to triangle ADE, reason, angle, angle, angle. Okay, so you would get a mark for every single line of that format. Okay, then I still need to prove it in another way. So now what I'm going to do is I'm going to remove the angles and I'm going to work only with the sides. Okay, so my similarity case 2, sides in proportion. I'm going to move that one triangle down so you can see a bit better. Okay, so that's what I'm working with. Okay, I'm going to say, I'm going to write the sides in proportion as fractions. So I'll say 32 over 24, 80 over 60, and 60 over 45, and see if they simplify to the same fraction or the same number. Okay, so I first state my triangles, then I write them as fractions. So line AB over line AD is 60 over 45, which simplifies to 4 over 3. Line BC, which is the short side here, over line DE, which is the other short side, is 32 over 24, which also simplifies to 4 over 3. And then the same thing for that really long line. So 80 over 60 also simplifies to 4 over 3. Okay, so that means that because they all simplify to the same fraction, the sides are in proportion. Notice here that there's no reasons needed for the step with the fractions. Okay guys, so for homework I would like you to do exercise 13.8 on page 139, number 1a. This is what it looks like. So you need to prove that each pair of triangles is similar. Okay, for some of them, what you might need to do is you might need to calculate the angle or the side first. So for example here, you're missing all the sides, so you would need to use Pythag to first work out the sides, then you can only show that they're in proportion. Same thing here, you're missing an angle over here, and over here you're also missing an angle, so first work out the angles, then prove similarity.